Howdy guys, this is Carlos Bocanegra from Intronic Systems, and today I'll be going over the advanced level functions. So right now I'm looking at the intermediate level for the temperature function. Again, how I got here from the main, I simply clicked on temperature, hit F3, it took me to the intermediate functions header file. From here I can see each function that was used to get this overall beginner level function. So for example, if we want to go into this function, the I2C receive bus 0 function, we click F3 again, and now we're in the full code for that function. This is what we consider the advanced level coding. So here we see that we're saying this function is not going to have any return variable, therefore it is void. We name our function. Then we're saying there's going to be two parameters to be included in this function. The first being a slave address, which has to be an unsigned char type. The second being the number of bytes to receive, which is an integer type. And for example, here we give it the temperature address, TMP102 address ground, which if we hit F3 to go into where it's at, we can see that it is a 0x48. So here, we are giving it 0x48 for the slave address, which is used here. As you can see, when I highlight one, it highlights where it's used. And then the number of bytes to receive, here we're saying it's going to be 2. So number of bytes to receive, which is used here, is used as 2. So I've gone through each of these lines, line by line, and explain what's going on. So just to go to a quick overview, first we're selecting the pins, so we can use them for I2C functionalities. We're selecting in this case 3.1 to be the SDA for I2C, and 3.2 to be the SEO, which is the data line and the clock line. Next, we're enabling the software reset, which we need to do before we configure any of the configuration registers. This is all the configurations that is needed for the I2C module on the MSP430. What we're doing is we're selecting the system master clock while keeping the software reset so that we can keep editing it. Then we're setting up the clock speed, which what we did here sets it up to around 100 kilohertz, which is takes the clock and divides it by the number we gave it, in this case 12. Finally, we're giving it the address, which again was given here in the parameter, function parameter. And then we're setting up clearing the software reset so that we can continue doing information. We're enabling the RX interrupt since this function is for receiving. We're loading up the RX byte counter for this bus, for bus 0, since this again is given by the parameter. We are then waiting until the stop condition got sent, sending the start condition, and then going into low power mode and enabling interrupts in order to receive the data. Finally, you can put a breakpoint right here, any space here that is blank, to be able to see what you got into that what you got from the buffer, doing a no operation, and then the code ends. So basically, the way it's working whenever it's getting I2C is all interrupt service based, which if you go all the way down in either this header file, or which is the USCI B0 I2C header file, or you go into the USCI B1 I2C header file, which this is for the internal bus and external bus 0, bus 1. Both of them at the very bottom have the interrupt service routine. So right here we have our interrupt service routine for our I2C bus 0. Here we're just detailing that the next bit of code is going to be interrupt code. Here we have a switch case, which is for our I2C module. We have different cases. We're not using any besides the RX, which is for receiving, and the TX, which is for transmitting, which is our case 10 and case 12. And these are done by twos. So it's 0, 2, 4, 6, 8, 10, 12. So for the receiving case, what it does is first decrements the received byte counter. Then it checks the received byte counter is at least something greater than 1. If it is, then it'll read that buffer and put it into whatever number the counter is. So for example, the counter was 1, it'll read the counter, be like it'll decrease the counter first, it'll know it's 0, and then it'll put that whatever's in the buffer on this string's 0 byte byte position. Then if the counter is 1, meaning it's going to be the last byte, it will transmit a stop condition so that we can ensure that so we know that receiving is done. Otherwise, it just gets the buffer information, puts it in that specified register, and it exits the low power mode. For transmitting, is very similar. It takes if the text transmitting byte counter is greater than 0, it'll transmit whatever's on this string with, again, according to whatever the byte counter is, transmit it to the I2C buffer, decrease the counter, and go on. If however this is not more than 1, or more than 0, sorry, they will just transmit the stop sign and it'll clear the transmit interrupt flag. So this is basically how the I2C functions work. And if you go through each of these codes, a lot of these are very similar since most of these sensors are I2C, but you can basically go through each one by pressing F3 again, and you can go through each one and see what I did with them by simply reading the comments.